SpaceX stands on the precipice of a new era in space exploration. This is not just a company, it is a vision, a dream that transcends the ordinary and ventures into the extraordinary. Their ambition? Achieving full and rapid reusability of spacecraft, a goal that, if realized, could revolutionize the way humanity interacts with the cosmos. This is a feat previously relegated to the realm of science fiction, a dream that seemed impossible until now. Central to this audacious goal is the development of a fully reusable heat shield, a critical component that must withstand the most extreme conditions. Elon Musk himself has dubbed this the greatest technological challenge, a testament to the complexity and importance of this endeavor. Picture a spacecraft, returning from the searing heat of atmospheric re-entry, its heat shield glowing from the intense friction and heat. Its heat shield bearing the scars of its perilous journey, each mark a story of survival and resilience. This shield is not merely a protective layer, it is the embodiment of dreams, of human ingenuity, and the relentless pursuit of progress. It represents the spirit of pushing the boundaries of what's possible, of daring to dream bigger and reach further. The quest for a reusable heat shield is a testament to SpaceX's unwavering commitment to revolutionizing space travel. It is a journey fraught with challenges, but also brimming with potential. It represents a paradigm shift, a departure from the wasteful practices of the past, where rockets were discarded after a single use, contributing to space debris and environmental concerns. With the advent of reusable technology, SpaceX envisions a future where space travel becomes as routine as air travel, a future where the stars are within our grasp. Imagine rockets launching, landing, and launching again, each mission bringing us closer to a new frontier. This technology unlocks the cosmos for generations to come, making space exploration more accessible and sustainable. The journey begins with understanding the sheer complexity of this challenge, and it continues with the relentless pursuit of innovation and excellence. SpaceX is not just building rockets, they are building the future. SpaceX's approach to reusability is nothing short of revolutionary. Unlike traditional space programs that relied on expendable rockets, SpaceX has designed its Falcon 9 and Falcon Heavy rockets with reusability in mind from the outset. The first stage boosters responsible for the initial ascent are designed to return to Earth and land vertically, either on land or on drone ships stationed at sea. However, the heat shield presents a unique challenge. While the first stage boosters experience relatively modest heating during their return, the upper stage, including the spacecraft itself, must withstand the inferno of atmospheric re-entry. Temperatures can reach a staggering 3,000 degrees Fahrenheit, hot enough to melt most metals. Elon Musk is known for his ambitious timelines, often pushing the boundaries of what's considered achievable. In the context of the fully reusable heat shield, Musk has set his sights on achieving high multi-flight reusability for Starship, SpaceX's next-generation spacecraft. This means that Starship should be capable of flying multiple missions with minimal refurbishment between flights, similar to commercial aircraft. While Musk hasn't publicly announced a specific timeline for this milestone, he has hinted that it could be achieved within the next few years. This aggressive timeline reflects Musk's belief in the power of rapid iteration and his unwavering determination to make life multiplanetary. The alchemy of heat engineering the impossible. Developing a heat shield capable of withstanding the extreme temperatures of atmospheric re-entry multiple times is a monumental engineering challenge. The intense heat generated during re-entry can reach temperatures as high as 1,650 degrees Celsius, which is enough to melt most conventional materials. This makes the task of creating a reliable heat shield not just a matter of engineering, but a true alchemical process of transforming raw materials into a protective barrier. SpaceX's approach involves a combination of innovative materials, advanced manufacturing techniques, and sophisticated thermal protection systems. The company has invested heavily in research and development to push the boundaries of what is possible. By leveraging cutting-edge technology and a relentless focus on innovation, SpaceX aims to create heat shields that are not only effective but also reusable, reducing the cost and increasing the frequency of space missions. One key development is the use of reusable ceramic tiles, similar to those used on the space shuttle. These tiles have been engineered to endure multiple re-entries, making them a cornerstone of SpaceX's thermal protection strategy. The ceramic tiles are meticulously inspected and tested to ensure they meet the rigorous standards required for space travel. However, SpaceX's tiles are larger, more robust, and designed for faster production and refurbishment. This allows for quicker turnaround times between missions, which is crucial for the company's ambitious schedule. The larger size of the tiles also means fewer seams and joints, reducing potential points of failure and increasing the overall durability of the heat shield. These tiles are made from a high-temperature ceramic material that can withstand extreme heat and thermal shock. The material's unique properties allow it to absorb and dissipate heat efficiently, protecting the spacecraft from the intense temperatures of re-entry. Engineers conduct extensive testing to ensure that the tiles can handle the harsh conditions of space travel. They are designed to ablate, meaning that they slowly vaporize during re-entry, carrying away heat and protecting the underlying structure. This ablation process is a critical feature that helps manage the extreme thermal loads experienced during re-entry. By gradually wearing away, the tiles effectively shield the spacecraft, ensuring a safe return to Earth. In addition to the tiles, SpaceX is also exploring other thermal protection technologies such as actively cooled metallic heat shields and inflatable heat shields. These alternative technologies offer unique advantages and could complement the ceramic tiles in future missions. Actively cooled metallic heat shields use a system of pumps and radiators to dissipate heat, while inflatable heat shields provide a lightweight and flexible option for protecting spacecraft. These technologies offer the potential for even greater reusability and could be crucial for future missions to Mars and beyond. As SpaceX continues to innovate and refine its thermal protection systems, the dream of sustainable, cost-effective space travel becomes ever more attainable. The advancements in heat shield technology are not just about surviving re-entry, they are about paving the way for humanity's next giant leap into the cosmos. Trial by fire, testing the limits. SpaceX's iterative approach to development is characterized by rigorous testing and a willingness to learn from both successes and failures. The company has conducted numerous high-altitude test flights of Starship prototypes, each flight providing valuable data on the performance of the heat shield and other critical systems. During these tests, SpaceX engineers closely monitor the performance of the heat shield, using a variety of sensors and cameras to track temperature, pressure, and structural integrity. The data from these tests is then used to refine the design of the heat shield and improve its performance for future flights. The Starship ecosystem, a symphony of innovation. The development of the fully reusable heat shield is just one piece of the puzzle in SpaceX's grand vision for Starship. This heat shield is designed to withstand the intense heat of re-entry, ensuring the spacecraft can be used multiple times without significant wear and tear. The company is also developing a suite of other technologies such as the powerful Raptor engines, which are fueled by liquid methane and liquid oxygen. These engines are not only more efficient but also more environmentally friendly compared to traditional rocket fuels. The massive Super Heavy booster, and the Mechazilla launch tower, all of which are essential for achieving full and rapid reusability. The Super Heavy booster with its 33 Raptor engines provides the necessary thrust to propel Starship into orbit. Mechazilla, for example, is a testament to SpaceX's innovative spirit. This towering structure is equipped with robotic arms designed to catch the returning booster mid-air, a feat that has never been attempted before. This colossal launch tower is designed to not only support Starship during its ascent, but also to catch the returning booster and spacecraft, ensuring they can be quickly refurbished and relaunched, eliminating the need for costly and time-consuming recovery operations at sea. This innovation significantly reduces turnaround time between launches, making space travel more efficient. These technologies working in concert will enable SpaceX to dramatically reduce the cost of space travel, paving the way for more frequent and affordable missions, making it possible to send humans and cargo to Mars and beyond on a regular basis. This vision of interplanetary travel is no longer a distant dream, but a tangible goal within our reach, thanks to SpaceX's relentless pursuit of innovation. A giant leap for humanity. SpaceX's pursuit of a fully reusable heat shield is not merely a technological marvel, it is a testament to the indomitable spirit of human ingenuity. It represents a fundamental shift in our relationship with space, from one of tentative exploration to one of sustainable presence. The implications of this technology are far-reaching. With fully reusable spacecraft, we can finally unlock the potential of space, not just for scientific discovery, but for economic development, resource utilization, and the long-term survival of our species. As SpaceX continues to push the boundaries of what's possible, we stand on the verge of a new era in space exploration, an era where the stars are no longer a distant dream, but a tangible destination within our reach.